Hi, I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of algebra within the Year 11 standard course, and we're looking at linear relationships, which comes under MSA2. So firstly, we're going to look at graphing linear functions, and there's different types of linear functions, so we are going to start with straight line graphs. So hopefully you are all familiar with the equation of a straight line, and the equation of a straight line is y equals mx plus b. So in the equation of the straight line, our m is our gradient, and that is the slope of the line. And we calculate the slope of the line by doing rise over run. And then we have our B, and our B is our y-intercept. So wherever our straight line crosses the y-axis, that will be our y-intercept. So on a number plane, just like this one that I've got up here, we have a horizontal line, which is going to be our horizontal axis, and that's our x-axis. So any values along this horizontal line are going to be our x values. And then the vertical axis is going to be our y1. And so all the y values will go through here. So if we have 1, 2, 3, 4, for example, and we have a line going through like this, wherever our line crosses the y-axis, that is going to be the y-intercept. So our y-intercept for this straight line here is going to be 3, because it crosses the y-axis at the point of 3. If I were to put values onto the x-axis, and 2, 4, 6, for example, 2, 4, 6, 8, like this, and then I was to calculate my gradient, we do rise over run. And rise over run is where you make a triangle and for your rise and for your run. So what that means is that you find 2 points on your graph. So I'm going to choose this point and my y-intercept point. And then as you can see where my red line goes, it kind of makes a triangle. And so my rise is going to be along the y-axis. So that's going to be my rise. And my run is going to be along the x-axis from that point to the triangle. So the base of the triangle is the run, and the height of the triangle is the rise. We can ignore the hypotenuse if we pretend that that's a right angle. So what that means is we do rise over run. So if my rise is from 0 at the origin to 3, I have a rise of 3. And if my run is from 0 to 6, I'll have a run of 6. And 3 on 6 just equals 1/2. And so my gradient or my slope of the line is going to be 1/2. The slope of the line will change depending on the angle the line makes. So if it makes a very steep angle, it will have a different gradient compared to a line that makes a very long or slanted angle. So that's how you calculate rise over run. You do the difference from one point to the other point on your run and from one point to the other point for your rise. So there's some features of your straight line graph which hopefully you are familiar with. So let's move on to the next slide. So when we're drawing or constructing a straight line graph, we can use these steps here. So firstly, our first step would be to construct a table of values. So by constructing a table of values, you will get a set of values for x and y, which you can plot onto your number plane. So how we construct a table of values is by putting the x on top and the y on the bottom. And you put random values for x in there unless they specify. If they specify, use the values they give you for x. If they don't, you can make up your own values. For example, -2, -1, 0, 1, and 2. They are my go-to values for x. And so if we do questions, I'll probably use these values. So it says construct a table of values with the independent variable as the first row. So that will be our x is going to be the independent, and the dependent variable as the second row. Dependent. So what that means is if we have a number plane, our x is on the horizontal axis, so it is independent, and the y is on the vertical axis, so it is dependent. Now, easy way to remember what is which, whether independent goes with x or independent goes with y, is that you think of this as the ground, the horizontal ground. And the ground will always be there. If you step outside of your house, you will step onto the ground. The ground will always be there. It doesn't depend on anything. Whereas if you have a building in yellow, the building is dependent on the ground being there. If the ground was to break, for example, an earthquake, then the building would fall because it is dependent on the ground. So that is how I remember it, that the building is dependent, so the y is dependent on the ground, and that means that the ground, our x, is independent. It does not need anything to stay there. It will just stay there unless there's an earthquake or anything. So that's an easy way to remember the independent and dependent variables. Number 2 says draw a number plane with the independent, which is our x, and dependent variables. And so we draw up a number plane, put these points onto the number plane. So if it was 1, 4, for example, you go across to 1 on the x, and then you go up to 4 on your y and put a point there. Step 3 says join the points to make a straight line. So our points might go like this, and so then we would join them together to make a straight line. So that's the steps for constructing a straight line graph. Draw a table of values, plot the points, and connect the points. So let's have a go at doing some examples. So here we have the straight line equation of y equals 3x. So if we have y equals 3x, we know that the number out the front of the x is going to match up and be our gradient. So 3 is going to be our m, which is our gradient, or the slope of the line. If we have a look for b in this equation of the straight line, y equals 3x, we don't have a b, so we have no y-intercept. And that tells us that this straight line is going to pass through the origin, and it's going to pass through 0, 0, so that there is no y-intercept. So let's have a go at drawing this straight line. And if you remember, our first step is to draw a table of values. And when you draw a table of values, the x is our independent, so it goes on top, and our y is dependent, so it goes on the bottom. So then we can sub in our own values for x. I'm going to do -2, -1, 0, 1, and 2. And now we sub our x values into the equation. So y is going to equal 3 times -2 for our x value of -2. And if you get your calculator out and you put in y equals 3 times -2, we will end up with -6. Now we can continue that for the rest of them. So y equals 3 times -1. You just want to sub your x values into the x position of your equation. All right, and when you've done that, we can draw up a number plane. Remember, our x goes on the horizontal axis because it is independent, and the y goes on the vertical axis because it is dependent. So now we can put on our points. So we have -2 here, -1, then we have 0, 1, and 2. And then on our y-axis, we have to go up to -6. So we're going to go 1, 2, 3, 4, 5, 6, -6. And we have to go all the way up to 6 as well. 1, 2, 3, 4, 5, 6. So when you do a question in your exam, for example, you will hopefully have grid paper, which means your graphing will be accurate and evenly spaced. Because I'm just doing this on the computer, I don't have a method to evenly space out my lines. So it might not be the most accurate graph, but it will do for the purposes of the video. So now I'm going to put my points on. So if I have -2 on my x-axis and I go down to -6, that will be about there. -1 on my x-axis is going to give me 1 on my y-axis. Actually, it should give me not -1, it should give me 3. 3 times -1 should be -3. I don't know what happened there. Sorry about that. -3. So 1, 2, 3, it should be about there. Then we have 0, 0. Then we have 1, 3. And lastly, we have 2, 6. So now we can connect these dots with a straight line. And that will be our straight line graph for the equation of the line y equals 3x. So let's have a go at doing another example. The next example is going to be a little bit different because the gradient or our x is actually going to be negative. And if we have a negative graph, it's going to go in the other direction. So if it's negative, the values heading in the along the x-axis, all these values here are going to be negative. So under our line, the x-axis is going in a negative direction. Whereas if we have a look at the pink one, which is positive, the x-axis is heading in a positive direction. And so everything under there will be positive. And so that's the difference between the two. An easy way to remember, if the line is facing this way, like the yellow one, then it's a negative line. And if it's facing the other way, like the pink one, then it's a positive line. So we just did a positive line because our x was positive. And now we're going to see a negative line because our x is going to be negative. So if we see here, our next is at negative, which indicates that our line is going to be facing that way. In that direction is going to be negative values because it is a negative line. So there's two ways to tell if your straight line is going to be negative. If you are given a graph, if you're given two graphs, for example, and they say which one's negative, we know that anything in this going in that direction is negative. So this one would be the negative one, and anything in that direction is positive. So that won't be the negative one. So if you're reading off a graph, look for the direction of the line and it will tell you whether it's negative or positive. And if you're reading off an equation, if your x is negative, it will be negative. And if your x is positive with no negative out the front, then it will obviously be positive. So let's have a go at drawing this graph. Our first step, as always, is to draw a table of values. So we have x and then y. We can choose our x values because they didn't specify. So I'm going to do -1, -2, -1, 0, 1, 2. And now we can sub in and get it correct the values for y. So y equals -x, so it's going to be -2 minus 2. And so if you put that into your calculator, you will get 0. So -2, we know that a minus and a minus gives you a positive. So then we have 2 minus 2, because it's a positive now, and +2 minus 2 just gives us 0. So hopefully you're familiar with that. Otherwise, I'll just recap. A negative and a negative gives you a positive and a positive gives you a positive, a negative and a positive gives you a negative. So those are just to keep in mind. In this case, we had 2 negatives. We had this negative here and this negative here next to each other, and so it becomes a positive. So let's go ahead and fill in the rest of the values for x. So -1 minus 2 leaves us with -1. -0 minus 2 leaves us with -2. And -1 minus 2 leaves us with -3. And then finally, -2 minus 2 leaves us with -4. So now we've got our values for x and y. We can draw up a number plane. And hopefully you're sick of hearing me say it, but x is independent, so it's horizontal. Y is dependent, so it's vertical. And now we need to put on our scale. So we have -2, -1, -1, 0, 1, 2. And then we have our y. Our y is pretty much all negative values. So we're going to have -1, -2, -3, -4, and then 1, 2, 3, and 4. So now we've got our scale and our number plane ready. We can put the points from the table of values onto our number plane. So if we have -2 along the horizontal and then 0 on the y, we'll just be flat on the y at 0 here. Then we have -1 and then -1, so we're going down. Then we have 0 on the x, which is just here at the origin, and -2, so it's down there. Then we have 1 on the x and goes down to -3, and then 2 on the x goes down to -4. So we can see that when I draw a straight line connecting these dots, it's going to go in the negative direction. So this is the straight line graph for y equals -x minus 2. So there's a few things in graphing straight lines to remember. You need to remember your y-intercept, which equals b. You need to remember your m is your gradient, which is rise over run. Remember x is horizontal or independent, and y is your vertical or dependent. We have positive and negative graphs. So positive x equals a graph going in that direction, a line going in that direction, and negative x equals a line going in the other direction. So there are a couple of summary points for the features of a straight line. And just remember to graph a straight line, always put it first into a table of values and then put those points that you get for x and y onto a number plane.